Hey there, and welcome. Have you ever stopped to think about the invisible magic that's happening inside your phone or your computer every single second? Well, today, we're going to pull back that curtain on two of the most fundamental, most important components that make our entire digital world tick. So let's get into it, starting with a question you've probably never even thought to ask. Seriously, think about your keyboard for a sec. It's got, over 100 keys? Each one needs to send a totally different signal. So why don't you have 100 different wires snaking out of it into your computer? How does all that information get squeezed through just one single cable? I mean, can you imagine trying to use one wire for every single key? You'd have an absolute information traffic jam. It'd be a messy, expensive, and just ridiculously impractical rat's nest of cables. Thankfully, engineers came up with a much more elegant solution. And it all comes down to a really clever code. You know, this wiring problem was the fundamental hurdle that had to be cleared to take technology from these massive, room-sized machines to the sleek devices we all have in our pockets today. So how did they solve it? Well, the solution starts with this brilliant little component called an encoder. And honestly, the easiest way to think about it is as a data compressor, but for electrical signals. So an encoder's entire job is to take a whole bunch of input wires, see which one of them is active, and then convert that into a super compact coded message using just a few output wires. It's a simple kind of circuit that doesn't need any memory. It just instantly translates whatever comes in. And get this compression is incredibly powerful. A really common type of encoder can take 16 separate input lines and represent any one of them using just 4 output lines. That's a 75% reduction in wiring, which is a massive deal in terms of saving space, money, and complexity. And this little chart, this truth table, shows you exactly how it works. Let's just follow one. See the row where input 2 has a 1? That means it's the active key. Now follow that row all the way to the right. The encoder spits out a 1 on output A and a 0 on output B. That binary code, 1-0, is simply the number 2. It's a perfect, totally efficient translation system. Okay, so we've successfully compressed our signal into this neat little binary code. But a coded message is pretty useless if the person on the other end can't understand it, right? That's where the encoder's essential partner comes into play, the decoder. The decoder, which is another one of these simple circuits, does exactly what its name suggests. It takes that compact binary code, our 1-0s from before, and it unpacks it at the destination. It uses that code to activate one and only one of its many output lines. So in our example, it lights up line number 2, and the computer knows exactly which key was pressed. Simple as that. So, encoders and decoders are this fantastic little messaging system. They compress, send, and expand data to save a ton of space. But what if I told you that wasn't even their most amazing trick? This is where the story gets a really surprising twist. Which brings up a really cool question. Are these circuits just the postal workers of the digital world, just passing messages along? Or can they actually think? And the answer is a resounding yes. It turns out these simple circuits are so fundamental that they can be cleverly repurposed to build the very logic that performs calculations deep inside your computer. This is a brilliant example of how you can build something called a full adder, which is a basic circuit for adding binary numbers using just a decoder. First, you feed the bits you want to add into the decoder's inputs. Then the decoder does its thing, and its outputs, these min terms, basically represent every possible answer. And from there, you just use a couple of simple logic gates to combine the specific outputs that give you the sum and the carry results. It's incredible. You've just turned a message unpacker into a tiny calculator. And hey, this isn't just some fun little theory. This is a real-world engineering technique. Using a single decoder chip, or IC, to perform logic is super common because, as this quote points out, it reduces the space needed on the circuit board and, crucially, it reduces the cost. It's just flat-out smart, efficient design. So when you kind of step back and look at the big picture, you start to see that encoders and decoders aren't just one-trick ponies. They're way more like fundamental building blocks, like the Lego bricks that engineers use to build the complex digital world we all rely on every single day. So, to wrap it all up, encoders compress data to solve that information traffic jam, and decoders expand it so the message gets through loud and clear. But the real takeaway, the really mind-blowing part, is that this simple act of decoding has this hidden power. Its logical structure makes it a super versatile tool for building the very brains of our devices. It really makes you wonder, doesn't it? From your keyboard all the way to your processor, our technology is built on these layers of simple, elegant solutions. What other ingenious building blocks are hiding in plain sight, quietly running your world? Thanks for joining me for this one.